yesterday. I started recording so that later on, if you want, you can use this.
Yeah, fine, okay.
Yeah.
You can upload to some drive, so I will
Yeah, I will.
download it from my end. Yeah.
Yeah, I'll do that. Yeah.
Okay.
Okay. So yesterday, I am sharing my screen. Yeah.
Okay.
So yesterday, we saw what all responsibilities or functionalities of main node and data node is, and today let's see how
Yeah.
a file write happens in HDFS.
Okay.
Okay, so first thing is we have a client and we have a cluster here on this. Okay, I'm using some old slides. Okay, later on I'll change this
Oh,
logo. Yeah, so this logo is mine only. Okay, don't think that it's some training
okay.
institute or something. This is mine only.
Okay. Fine. Okay.
Yeah, so this is a cluster that we saw earlier when we are trying to understand the architecture of Hadoop. So now
Okay.
let's try getting into file write operation. Step one, client gets a request to create a new file. Okay, so
Okay.
let's say this is a client machine on that some Java application or something is running, and due to that there is a need for us to create a new file on the cluster. Let's say our file is file.txt, which is of size 150 MB. Okay.
Okay.
Now, what will client do is client will first calculate the number of blocks to create, and for this it uses a configuration parameter called DFS block size. Since we are installing Hadoop on all the machines, servers and all, right, it has the default
Yeah.
configuration files, also the user defined configuration files. So anytime it wants to do any operation, these configuration files are read, and one of the configuration
Okay.
parameter that we are interested in this write operation is dfs.block size. By default, for Hadoop 1.0 it is 64 MB, for Hadoop 2.0 it is
Yeah.
128 MB.
Oh, 120. Okay. Yeah.
Yeah,
Fine. Okay.
yeah, they have increased it.
Yeah.
Okay, once it reads the configuration file, it comes to know
Okay.
what is the default block size. The block size that we are talking, it is actually a HDFS block size. Okay.
Yes. Okay.
Okay, then it will compute the number of blocks to create. Number of blocks to create is equal to file size divided by HDFS block size. Assuming we are using 1.0, we will get 150 divided by 64, that it comes to 3 blocks.
Okay. Yeah.
So first block would be of 64 size. The second block is also
Yeah.
64
Right.
size. 128, 128, 30. So third would be 22.
22. Yeah.
Yeah. Okay, this way it comes to this way.
Yeah. Fine.
These are the blocks that we would be creating. Now what this guy will do is, since your file, okay, I'm giving you extra information now. Since this file is in Linux file
Yeah.
system, okay, it is in Linux.
Okay. Okay. Oh, we have to move to HDFS framework.
Yes. Internally,
Okay.
here we have a HDFS file system. First, the client will try
Okay.
to buffer the data of this file into the HDFS temporary space.
Okay.
Okay, what it does is the content of this file will be like it will be, I don't know internally how it works. So what I know at a high level is the content of this file would be transferred to a temporary location. Maybe it's sort of copy and all. Once 64 MB of data is available in the HDFS temp location, let's say slash temp location, then client will send a request to name node asking for file creation.
Okay. So that means if I'm not wrong, okay. I mean it's a queue based mechanism because the slash temp is a no normal hard drive temp. It's not RAM.
It's not RAM. Yes, it's not RAM.
Okay. So
So
as and when yeah.
no. I don't want to give wrong information to you. I really don't know whether
Okay.
it is definitely it will not be loaded into RAM. Okay, because we are moving the
Yeah.
file
Fine.
from
Yeah.
Linux file system to HDFS. So
Yeah.
HDFS
Right.
file system, when I talk, so it is exactly similar to your Linux file system. The only difference is
Yeah.
somewhere in slash temp of Linux, okay, slash temp, let's say slash Hadoop,
Okay.
the HDFS file system would be mounted.
Okay.
Okay, whatever that gets created under, let's say this is a path which we have given as a part of our configuration file to HDFS, saying that under this
Hmm.
path HDFS should create its all files. So this is a Linux path.
Okay.
This is a Linux path. Okay.
Okay. Okay. Yeah.
So
Okay.
under this, the ownership is given to HDFS now, Hadoop HDFS.
Okay. Okay. Yeah. Fine.
Okay.
Fine. Okay. Okay.
1 minute. China, class is there, Amma, Amma. So under this, the HDFS will start creating all its files, directories, everything.
Okay.
Okay. Now,
Okay.
what probably they are doing is somewhere within this directory they might have a folder called temp, where they would be storing the intermediate data. So looks like
Okay.
once the file from this file.txt is getting transported to temp, and some process is monitoring to see what is the size of this current file that is getting transferred to HDFS. Once it reaches a size of 64, where it can create first block, right? Client will send a request to
Okay.
name node asking for a file creation.
Yeah. Fine. Okay. Okay. Yeah.
Okay, let me clear
Sure. Sure.
this.
Okay. Yeah.
So, so then what, like the file, this file is like at a high level, this is how I show, but internally, whatever I explained to you, right, that's how it happens. The client,
Yeah.
I generally, I tell to the people that the file is broken into 3 blocks because we need to create 3 blocks. It's not necessary for everyone to know how internally it is doing and all.
Okay. 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 Yeah. Yeah.
Now,
Fine. Okay.
whenever client creates a block, there is something called block ID. Okay. So each
Okay.
block is assigned a block ID and the length of the block is 64-bit.
Yeah. Okay.
Okay, and this block ID, which is of length 64-bit, it's unique within the cluster.
Yes. Okay.
Okay, so that we have these
Yeah.
many data nodes, and anywhere you put any block.
Okay.
Oh, 1 minute.
Yeah. Sure. 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 Okay.
Please, class. My son is traveling.
Okay. Okay. Problem. You take some time. Okay.
No, no,
No
no, no,
problem.
no. My wife is
Okay.
taking care, so he's complaining something.
Uh,
Okay, so any block that is stored on any of these data blocks can be uniquely identified. There won't be any clash.
okay. Okay. Fine. Fine. Okay.
Okay, now another thing that you
Okay.
might be thinking, when I have three replicas, okay, will the
Yeah.
block ID be same? Ideally, it should not be, but I really don't know. I have not gone to that extent whether the block ID will be same or not. If you
Okay.
take the three replicas, but at least we have something called block
Okay.
ID, which is of length 64-bit.
Okay. Okay.
So then
Then.
the client will send a message to name node to saying that I want to create a file.txt with the 3 blocks.
Uh, one moment. Sorry, Venkatesh.
Hmm.
When you say the length of the block is 64 bit,
Length of the
64 bit.
block ID. Block ID. I didn't
Oh,
say.
okay, oh, block ID. Okay, yeah, fine, fine. Okay, okay. Yeah, click, 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 click.
Okay. Yeah.
Yeah. I mean,
Client will.
so the means, I mean, you create n number of blocks.
Mhm.
Still, even then that bit can hold that block name
Yes,
by
yes,
right.
yes. So when I say
Okay.
64, which means I will be able to create 2 raised to 64 minus 1 blocks.
Yes.
So
Yes,
this is
yes,
a
yes,
huge
right.
number.
Okay.
Yeah.
Yeah, yeah, right.
Okay. So then client sends a message to name node asking for a request to create a new file. Usually in HDFS, what happens is there is no concept of current directory. So in my Linux, if I log in, it will be something like home slash
Yeah, home,
Venki.
home. Yeah.
Yeah.
Yeah,
Something like
right.
this is
Okay,
my,
that's a username.
yeah. So this is my current directory. But in HDFS, all
Yeah.
the file name should be explicitly specified by absolute path, the complete path.
Okay.
Okay,
Okay.
the directory structure is
Okay.
exactly similar to your Linux directory structure. The way we have folders, the way we
Okay.
have files within the folder, it will be similar. But the reference to the files would be done by the complete path.
Okay. So, on HDFS, you will not have any user IDs.
User IDs would be there, but we won't have current directory concept.
Okay. Yeah. Fine then. Okay. Okay.
Yeah.
Okay.
Okay. So then it will ask for request to create the file. Then what name node will do? It first needs to do some initial basic checkings. That is once the request for file creation comes, it will see whether the given user has a permission to create a file in this particular directory. Let's say in HDFS, I want to, I will show when I go to the hands-on, we have something called user slash HD user. Okay, this is the
Okay.
user that I have
Yeah.
created. Let's say under that I have a directory called directory one, and under that I want to create file.txt. Okay,
Okay.
let's say you are trying to create under this, but this folder, this username is mine, hd user is mine. What for
Yes.
name node will do is, as a part of namespace maintenance activity, it will go and see if Soma has a permission to write in this folder. If not, it will send back a response saying that error. If I am trying to
Okay.
create a file, then it will do a basic check to see whether I have a permission to create in this particular folder. Do we have a file with the same name? Whatever typical checks that are done by the file system on any operating system, the same check
Yeah.
will be done.
Right.
It will respond back with the list of data nodes. Okay.
Okay.
The replication
Okay.
factor is 3.
Okay.
The replication factor is 3. For that reason, we have 3 data node identities sent back: DN2, DN8,
Okay.
DN11. Okay,
Okay.
if
Okay.
the
Okay.
replication is more, probably this will change. So by sending back this response, what name node is informing to the client is, can you please go and write your first block to data node 2, 8 and 11.
Okay.
For the first block, we have 3 blocks. I'm talking about first block. Okay.
No, I mean when you hear data node two, okay. So data node one will have an issue or
No, no, no. See, now you are asking me a question on what basis name node has picked these 3 data nodes, right?
yes, yes, yes.
Okay. There is an internal algorithm basis of that it is actually picking this. Okay, they have built in algorithm. Details of that I don't think they have exposed and all. We need to probably look into the source code based on various factors, the load distribution. Okay, the rack awareness concept that we are going to study. Okay, then
Okay.
so some factors they have considered: how many nodes are busy, what they are doing. They would have they consider all that, and finally they respond back with this one. For time being, what I would say is, we have an algorithm. You give in the request to that saying that I want to create a new block, and replication is factor is 3. It will do all internal checks and finally return me 3 data nodes IP address.
Okay, so I mean, you mentioned now if I say okay, if I have like around 20 data nodes,
Mm-hmm.
I cannot say that okay, these three blocks has to go to data 2, 3, and 4, right? So it is only the internal that algorithm decides where it has to be set.
Yes, 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 yes. Client doesn't have a right. Name node, internal data node has a that algorithm which is
Okay,
deciding
okay,
where it
fine.
should go.
So if we want to check, right, so we have to check manually by viewing all the nodes by right.
No, no, no. That would be tricky. So if you are talking about a real cluster, because every block is marked as a block ID, so the file name would be like block underscore 000. Some big number will be there. How will you trace? So other
No, no, no,
alternatives.
no, no. For example, yeah, no, no, sorry. Because since we don't have any other files on HDFS, this is the first time.
Mhm.
So then there should be three blocks in any of the 20 nodes. So if you
Yes.
go and check, somewhere it has to be three.
Yes, it will be there. Yes, you are right. That is one way,
Yeah.
or we
Yeah.
can
Okay.
even go to the FS image. We can use a tool to convert a binary FS image to the text readable format, and we can check that way also.
Okay. So this is an interface then.
Which one is the interface?
That what is it? What is it? FS image?
Yeah, file system image. Yesterday we
Okay.
studied, right?
So the yeah, right. Okay. This we need to install or that can come. comes with a framework.
FS image is there in the name node. Okay, it is a metadata file. Okay, for us to
Oh,
convert
okay,
the
okay.
binary file to text file, okay, human readable format, there is an installer or some script, I think, which we need to download from Apache website or somewhere. I haven't used it, but we need to download that and then convert this. That will give us a human readable format.
Okay, okay, fine.
Let's see in
Sure.
hands-on session we try downloading that and converting that. Anyway, I also should know that. We will try it out. So maybe in my
Yeah,
free,
fine.
free time I'll try it out and then I'll show it to you.
Yeah, yeah, fine. Okay, okay.
Yeah.
Sure.
So now name node is coming back to client saying that can you please write the new block first block to these three data nodes because replication factor is 3. What name node will do is
Yes.
before it starts transmitting, right, first it sets up a connection with data node 2. Okay,
Okay.
TCP connection. On this, it sends a message
Yeah.
saying that please get ready to receive the data. At the same
Uh,
time, it will also tell to the data node 2 through some messaging that can you please set up the same TCP connection with data node 8 and 11. This guy will set up a TCP connection with the 8 and 8 in turn sets up a connection with 11. Okay, once 11's TCP connection is up, it sends back a response ACK probably, which comes all the way up to client. Now client knows that.
oh, so
Hmm.
Oh, so now by right, okay, it has to be one to one, right? Okay, for example, the client with the data node 2 and the client with the data node 8 and the client with the data node 11.
Uh, we can do that, but if you try to do this way, right, your write operation will be more optimal. For instance, see this rack 2, data node 8 and 11 are within the same rack, which means the rate at which the data is
Okay.
getting transmitted is here, right, it is far higher or more than the rate at which the data is getting transmitted between 2 and 8, because here this is an inter switch, this is intra switch.
Yeah.
So for that
Yeah, right.
reason,
Okay. So no. So sorry. The blocks will first copy to data node 2 and then to 8 and then to 11.
yes. So I'll come to that.
Is that so?
I'll come to that. So that is the next
Okay.
step. So is it okay now? So the client is setting up a TC
Yeah,
connection with
can.
the
Okay,
two.
okay, okay.
Yeah.
Yeah, fine.
Okay. Once
Yeah.
this guy gets acknowledgement, the client will start sending the data on the TCP streaming protocol. Client DN2, what it will do is as soon as it receives the data, it will start writing the data to its local hard disk. At the same time, another copy would return to the outgoing TCP connection so that 8 can receive the data. 8 will repeat the same procedure, but 11, it doesn't have outgoing connection, so it doesn't write down to the outgoing connection, but it will go and write all the data to the hard disk.
Okay.
Okay,
Okay,
once
okay.
everything is written,
Yeah.
okay, first block we are only writing first block. Once 64 MB of data is transmitted by the client, okay, it goes all the way up to 2 to 8, 8 to 11. The final act will come back to the client. This is where the client is coming to know that the write operation is successful. So to
Okay.
explain the same concept, the way I understood is, since we are using TCP, which means if I have to send the packets from source to destination, I'll be sending the TCP packets. For every packet that is sent to the receiver, I need to get a ACK because TCP is a
Yes,
acknowledgement
yes.
of transfer. When I send the last
Yeah,
sequence
yes, yes.
packet with last sequence number, the moment I receive a ACK from the client, it means to say that my data transfer is successful. So I will release the connection now.
Yes, okay. Yeah.
Okay, this is how it
Okay.
happens
Yeah.
at a TCP level. Now that now what it will do is, so this is how I show it to other people. So first block would be copied to data node 2, which in turn transfers the data to 8, 8 to 11. This is how the data is copied to all the three nodes. The ACK is sent to the client. The client comes to know that it has successfully written the data to all these three slaves. At the same time, the slaves will send a message to name node. What is that message?
No, okay.
Yesterday we saw that. What is that? Do you remember?
I mean,
What?
that should be the path and the information about the file, right?
Yes.
The metadata
Yes. It sends a message called block received.
block. Okay.
Okay, so this will have some statistic information like what is the size of the data block and what is a checksum, when was it created, some
Yeah.
statistics which is maintained by the data node.
Yeah.
So
Okay. Okay.
when a client requested the data node or name node, it actually created an entry in the edit log, but it didn't commit the changes. When it receives all the three responses from the slave node saying that we received a block and all, right? That's when name node goes and
Yeah.
commits and updates the entry into the metadata saying that a new block has been created.
Okay. Okay. Yeah.
Yeah.
Okay.
Okay. So now the whole so now after once this is done, client gets an acknowledgement. Client will send another message called add block. So actually the initially whatever I said, right, I want to create a file.txt with block. The actual message that goes is called add block.
Okay.
Okay, so first time when it sends, the name node will send a response saying that these are the blocks where you need to create the data. Next time for writing the second block, client again sends the same message. This is an update to name node saying that I have, from client side, I have successfully written the previous block, if at all there was a write done. Okay, that is also a confirmation to name node saying that client has successfully written. And this is also a mechanism for name node to get the information that the lease needs to be renewed. The client has acquired a lock, that is lease on a write operation, that it was allotted to this client when it client was requesting for a write operation in the beginning. Now when it says add lock, the name node will go and revise the lock. It will extend the time based on some parameters. Okay.
Okay. So by right, okay, this trying to write operation will have happened twice for the same block.
No, no, it is not happening twice. First time it sent this message. I want to create a file.txt with three
Yeah.
blocks. So at that time, the actual message that is going, okay, this is a, for explanation we are using. If you ask me what is the actual message that is going, it is add block with some details saying that what is a block that it is trying to write. Okay.
Okay.
And this guy is the one who should allocate the block ID. Okay,
Yes.
here
Okay.
it will go like what is the file name, what is the size of the file, what is the path of the file, okay, who is the owner, some details like that. That is what will go as a part of this. Now this is a guy who will allocate the block ID, and he sends these details back to your client with along with your dn2, dn8, dn11. At this time
Okay.
all these entries, whatever modification to your files are actually maintained your transaction log, which is called as edit log.
Okay. 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 Yeah.
Okay, once the data node send
Yeah.
a block received, the transaction log would be updated by doing a commit saying that the block has been successfully written.
Okay.
And this is where your metadata is also getting updated.
Okay.
Okay. Okay. So now the process will repeat for the second block. The green block is also like it is talking to the name node. Name node has allocated the data node 10, 14, 17. It is going and writing there, and the process will repeat
Mm.
for third one.
Okay.
Something is missing here. Okay. The process will repeat for third one. This will also be copied here. Yeah, the blocks are here. Okay. This will also be copied. With this, the client is done with write operation.
Okay.
Okay. And
Yeah.
you see here, first block, uh, like the blocks are equally distributed. Okay. So this is
Yeah.
intentionally I have placed the blocks. So name node will also take care of distributing the blocks. In a proper way. Okay, it doesn't randomly pick the data nodes
Okay.
and all, but in proper way it distributes the blocks across the cluster.
Okay.
Okay,
Okay.
so
Okay.
this is another way of representing the same thing. Okay, so we have a original file which is broken into,
Okay. You break up.
yeah, so
4, 2, 3, 4, 5 parts. Yeah.
six blocks. Yeah, we broke into six, and we I'm naming it as six blocks,
6. Okay.
b1 to b6.
Yes.
And
Yes.
yeah, what happens is like for each block I'm showing only for b1 here, the replicas would be created.
Yeah.
B1 R1 B1 R2 B1 R3,
Oh,
and then each of these replicas would be copied to the different slave nodes. The yellow color ones are the slave nodes. This is your name node, this is your secondary name node.
okay.
I have missed these names. There is an updated one, so I took an older version, so that's why these are not updated. So this is
Yeah,
what is
fine.
happening. So B1 R1 is getting copied to your one slave, B1 R2 to another slave, and B1 R3 to another slave. Let me number this: 1, 2, 3, 4, 5,
Yeah.
6, 7, 8,
Okay,
9.
and one more point, Venkat. So sorry. Okay.
Yeah, go ahead.
Here, when you buy when you buy a rack cluster server or a machine, do you do LPAR? You do LPAR and you can install two HDFS, right? I mean two clusters, right?
No, I am not aware of helper. What is it?
No, because when you bring when you buy one server
Okay,
with some medium configuration,
right.
if you say okay, it has got a 4 core and RAM of 128 GB,
Okay,
okay, and R drive of 1 TB, right? Okay,
okay.
you can logically partition
Yes,
by assigning okay two core to one machine and two core to one machine and RAM of 64
yes.
GB to machine one and machine two and the drive will be divided equally. So
Yes.
these two machines, right,
Mhm.
will act as independent, but by right the hardware is one.
Right, right. Yes. So
So
see.
so on this the does HDFS works on LPAR as well?
What you are basically saying is you want to create virtual machines on the same physical machine, two virtual machine, and run the two HDFS data nodes on that, right? Helper, I don't know. So this is what your question looks
Right.
like.
Yeah, yeah, yeah. I mean, yeah. Right.
You can do that, so nothing is stopping you. So nobody is saying that you cannot run multiple daemons, and this can be done. But the problem is, if in case of hardware failure, we are already saying that our hardwares are of cheap quality. If your hardware fails, your two
Uh,
machines are going down now, not one.
yeah, right. True. Yeah, fine. Venkat. I got I mean answer for this one.
Yeah. So for
Yeah,
experimental purpose, you can do that, no problem. So but in real life, yeah, if you try to do that,
Okay.
then we are in problem.
Yeah, right.
So
Okay.
yeah, the slave nodes are numbered as 1, 2, 3, 4, 5, 6 up to 16, and this is how the metadata would look like. File F1 block B1 R1, it is stored on DD1. There is a typos and all which I have corrected in latest one. It should be data node 1. That is here. The first copy is copied here B1 R1.
Okay.
Second copy B1 R2 is copied to 12. This is your 12.
Okay. Yeah.
And the third
Yeah,
copy,
fine, Venkat. Okay.
yeah, third is copied to this
Yeah.
machine. This is how the metadata is updated.
Okay.
Yeah.
Okay.
Okay, so now read is more simple. Now that we have already written this file, okay, in last topic. So let's see how a read happens. There is a request to read file.txt. Client will go and talk to the name node saying that I want to read file.txt. Get the location of the blocks. It is asking for the locations. Okay,
Okay.
so the message which is sent, I think it is something block locations, get block locations or something.
Okay.
Okay, this is a message that is sent. What name node will do is it actually based on the file name that client is asking, right? Client doesn't know how the file is broken, how many blocks are there, where it is stored, what are the block IDs. It doesn't
Yes.
know anything. It has to give the file name. The name node will look into its metadata, and it will respond back with the list of block locations. It will
Yeah.
say the file is broken into three blocks, b1, b2, b3, and these are the locations. And these location, the way it is written, right, it has a preference. The 2 should be read first, followed by 8, followed by 9. In case that machine DN2 is not able to serve the client request for read, it should go and talk to
So
the next
D8
machine.
and yeah.
Yeah.
Okay. Clear. Okay.
Yeah, and then it will now set up a connection with the DN2. In this case, what the roles are reversed. The DN2 will write the data and client will receive the data, and it will go and buffer into the HDFS temp folder. Similarly, it will try to get the remaining blocks also. Once all the required block
Okay.
information is available, it will club that and put the file into the Linux file system if you're copying it to Linux.
Oh, this is right written file.
Yes.
Okay, so when I do a checksum of the previous file and the this file by right, it should be same.
Checksum, let me come to your question a little later. The moment block is received, along with the block's checksum is also there. The client is supposed to verify that. You remember yesterday I was saying that the client has authority to go and update the name node showing that there are corrupted blocks.
Yeah, right. Okay, I mean my question was because we had actual original file, for example, like a.txt, and we have saved in some source folder.
Mm-hmm.
Okay, now the same file we split into three blocks and we stored in the name nodes,
Mm-hmm.
and now we have to read the
Ah,
same file. Okay,
uh-huh.
and then we going to merge, and then I want
Understand.
to copy this to some output folder.
Correct, correct, correct.
So here we did not do any kind of operation. We just split the file and we just rejoin the files.
Right,
I mean
right.
blocks.
Yes.
So by right now, when I check the actual source file and this output file should be same.
Yes, yes, it should be same. Yes, you are right.
So the checksum also should be same, right?
Yes, the immediate answer is yes to you. But if checksum calculation, if you
Okay.
are considering some time or some other parameter, right, it may differ. But answer to your question is yes. So the original file
Yeah.
and this one,
Okay.
since they
Okay.
are same,
Yeah,
it
fine.
has to be same.
Okay, I got the answer because the create file date and time, right, this will change, so
Yes.
the checksum will not match then. Yeah, fine. Okay, I mean the file count and the file content will be same. The diff,
Content,
right?
yes. Yes, diff.
Uh, yeah, yes. Okay,
Okay.
yeah, fine, fine,
Diff will
Venkat.
not show anything to you. Yeah, it will say as both are same.
Yeah, right. Yes. Oh, yeah, Venkat. Okay, great. Yeah.
Yeah. So let me go to the next one. So this is what we were trying to create three copies, right? Let's try to see how this policy is defined. By default, Hadoop distributed file system follows this policy while it is trying to, create the blocks on different nodes within the cluster. This the policy is called as data block replica policy placement policy, and this is what it says. For any new block creation, okay, first replica of the original block is always written to a local node on on one particular node. Okay, the second replica
Okay.
of the block is written to a different node on a different rack. We are going to a different rack and some node within that rack. Okay, the third replica of the
Okay.
block is written to a node on the same rack. So this is how it looks like. Okay, so first if I
Yeah.
write
Okay.
this one, then I will go and write,
Yeah. Okay.
then I will go and write to this one, and the third block would be written here. Now if you see the our write operation, which means client would be talking to this particular data node, and this data node probably in turn talks to this guy, and then somehow like the piping is like I don't know how the piping is done. So I tried to match this, but it was not matching. You can try it
Okay.
out. See, as per policy, this is
Yeah.
the first block that is written, this is the second block that is written, this is the
Yeah.
third block that is written, which means client should actually talk to this block, this data node. This
Yes,
data
right.
node should set up a link here, and this guy should set up a link here.
Uh,
But this violates the concept of
yes.
transferring within the rack.
Yes, right. Okay. Yeah.
So there is
I
some
got the
logic
point.
which they are using internally, which is I'm not aware today.
Okay. Okay. So I mean, I could guess one point here because the first block, right? It'll go to I mean, as per your hair mark, the rack 2, right? O- Okay,
There is rack 2. Yes,
the
yes.
rack 2. Okay, so uh, this first write will have the complete message that okay, the file has to go to first rack 2,
Mm-hmm.
and then from rack in the same message, okay, there will be information about the rack 1, so it will copy there. The third parameter will be that implies that okay, it has to copy from rack 2 to rack 2 in the next cluster.
Could be. So
Yeah.
yeah, this is how it might be. But yeah, so I didn't find this information. I was trying to understand how they are internally creating pipes. Code, probably we have
Okay.
to check the code. But what you said, that is also
Yeah,
possible.
fine. Okay. Yeah. Okay. Okay. I mean, I'm not sure, but I'm just guessing
Same.
this.
Yeah. Okay, so
Yeah.
this policy, this is what it says. It says first replica of the original block is always written to a block. So in this case, this is what it would be. The second replica of the block is written to a different node on a different track, and this is where it is. The third replica of the block is written to a node on the same rack. Or by now that when I'm discussing, another possibility is also there. Okay, so probably this should be the way. So they first go and write to this rack, and the second replica has to be on a different rack, that is this one, and the third replica would be on the
Yeah.
same rack within the this is what it says, return to a node on the same rack. Then probably they are going to write here, I think. So this way you can set up a pipe.
Yeah. Yes. Yes. I mean, this should be the ideal way.
Yeah, so maybe this is how it is
Okay.
happening.
And yeah. Okay. I mean, yeah. If you don't have the rack system, then how it behaves actually? So it will go to any cluster, right?
Yes, yes. If you don't define the rack, there is a concept called network awareness, and that's where the name node comes to know about rack and individual data nodes that are deployed within the rack. Okay, if it is not there, if a rack concept is not there, it will assume that all these systems are part of only one rack.
Oh, okay, okay. So then it will fall under the same single track then. Okay.
Yes, yes, that's how it treats.
Okay, okay. Yeah.
Yeah.
Yeah, fine, fine, Venkat.
Yeah, name node always returns the block locations and its associated network distance. I think this will come to this one little later. The information will be used by the clients while reading
Okay.
the data blocks. We already saw in the preference order. Same thing is coming here. Okay. Okay. So now the
Mm,
blocks are distributed like this. So the same thing, whatever we saw in the previous slide. So I am showing in a pictorial way here.
yeah.
Okay, this is
Yeah,
again,
okay.
this improves your fault tolerance and high availability and performance. I say performance because let's say the map task is running here, and if it has to read the data, first preference would be given to the data that is located here in either of these server.
Okay.
Let's say these two guys were
Okay.
busy.
Okay.
Okay, they could not take the map task,
Okay.
so the task would be scheduled here, and this particular machine is asked to read the data from either of these servers.
Okay.
That's how we are increasing the performance. Okay. Let's come to the next. Let's come to the
Okay.
next topic, that is network distance in Hadoop. I think we should have this particular concept in our existing projects also. What we do is there are corrections. Okay, this is D2, and there is one more correction. R1, R2, R3, R4. Okay, let me see that. Okay, so this is how we can represent a typical data center. This is my root. Okay, and I have two data center, D1 and D2, and within that I have two racks, R1, R2, and within R1 I have three systems, node 1, node 2, node 3, and within R2 I have three more, similarly for R3 and R4. Okay, when I talk about network distance,
Okay.
okay, first is a node address. So if I want to know what is the node address of N8, this is a node address, data center slash rack slash node. This is how they represent. Data center is this one. Okay,
Yeah.
that is D2. Then what is a rack in
Yeah.
which it is put, that is R3. What is
Yeah.
the
Yeah.
node?
Okay. Okay.
Node. So this is how we say this is a address.
Yeah.
And
Yeah. Sure.
and we also make another
Yeah.
assumption that the distance between any node and its parent, okay, any node and its parent, this or this, okay, you
Yeah.
take any two nodes and its parent,
Yeah.
okay, that is always one, unit one. Okay, now if we have to
Yes. Yes.
compute,
Okay. Okay.
Now, if we have to compute the distance between any two nodes, let's say we are computing the distance between node N1 and N1, it is nothing but sum of their distance to the closest common parent. N1 to N1, the closest is no closest, the distance is 0.
Okay.
Okay, the distance between
Okay.
N1 to N2, I have to go like this: 1 plus 1,
Yes.
2.
Yeah. Okay. Okay.
The distance between
Okay.
N1 and N4, okay,
N1 and 4. Okay. It is 1, 2, 3, and 4.
yes, so that's what it is.
Okay.
Similarly, the
Okay.
distance
Okay.
between N1 and N7. So let me clear this. N1 and N7, 1,
Okay. N1.
2,
Oh,
3,
it'll come. It'll travel
4,
full. Okay.
yeah, 5,
Yeah.
6. So it's coming to 6.
Yeah.
This is
Yeah.
how we define the distance. This distance is used by name node in allocating the replica where the data should be replicated. Okay, and it will also be used by name node in scheduling the map jobs.
Okay.
Okay, internally how it does, it's all internal today. I haven't gone to that level because it's their core algorithm, but this is a concept they use. And the knowledge of name node having which node is in which rack and all, that is what we call it as rack awareness. Okay, it's a
Okay.
concept in
So I
which
mean, yeah. I mean, in this case, I mean, is that the same block has to close by? I mean, you mean say the distance between a replication has to be the same block. A replication has to be minimal. You mean to say that, or
No, no, no. I'm not saying anything with respect to replication. I'm only saying that this is how they represent all the nodes that are there in a cluster. Okay. And a cluster internally can
hmm,
have multiple data nodes. Nothing is stopping us. One is in Bangalore, one is in Singapore. We can connect that. So that is your
okay,
cluster. If there is okay, so this complete awareness is there in the name node. It knows which cluster is where, and which node is part of which cluster and all. Okay.
okay,
Okay, somewhere
okay,
probably it is using, let's say in data center no, one, if there is a client which is trying to access a particular file, probably it is directing that particular client to go and read the data block from N2. Maybe the second block is sitting in Singapore. Let's say this data center one is Bangalore.
yeah,
Okay, this is
yeah,
Singapore. Okay, so maybe the second block is here, third block is here for whatever reason. Okay, so you remember
okay,
that preference and all, maybe somewhere name node is using this network distance, and it is giving a preference to the client saying that can you please read from data node 2. In case if you are not able to read
okay,
from here, go and read it from Singapore server.
yeah,
So some
got
internal
it, got it,
logic they
got it.
have done.
Okay,
Okay, yeah,
yeah, that's what the I mean. It is a shortest path first
yeah, right, you are right.
algorithm.
Yes.
Okay, okay,
Okay. So rack awareness, it's a concept in which Hadoop is configured to have the knowledge of network topology. We saw the tree structure, that is your network topology. Default configuration, this is what you are asking. Default configuration of Hadoop installation is single rack.
okay,
Okay. This is you know already. So intra rack transfer operations are preferred compared to the inter rack transfer when scheduling the map task.
okay. Intra try transfer operation of preferred compared to inter. Okay, yeah,
Okay.
okay,
Yeah. Now, the next question is how do we configure the rack awareness? Who take care of this? Actually, Hadoop provides some scripts. By running that script, okay, we can actually, the name node or somebody internally they build all this rack awareness topology and all. I think we need to give the IP address saying that which IP is what, some internal details and all, switch and IP details and all. The script will take this IP address as a inputs, and then it will calculate the complete network distance and all, and it creates this rack awareness concept internally, which would be used for further future scheduling. I haven't tried this.
okay,
I didn't have a real cluster, so I
okay.
couldn't try. But there are scripts provided by Apache.
So all these tasks are again done by admin only.
Yes, you are right. Admin has to do this.
Okay, okay, okay. Yeah,
Okay.
sure. Yeah.
Yeah. Okay, this is an old one, right? There is a process called checkpointing. Okay, give me a minute. So let me pull out. Maybe I have to log off from current user. Just be online.
Yeah,
So you may.
yeah, okay.
Yeah, so I need to get the new slides. Switch user.
Hello, hello, Venkat.
Yeah. Uh, are you able to see the screen now?
Yes, Venkat.
Yeah. Okay. So we completed this. So these are the latest slide. Okay. So here I have added the checkpointing process. So before we get into the process called checkpointing, let's spend some time in metadata.
Okay,
Okay. The previous topic was rack awareness. So now we are coming to persistent metadata information. Name node stores HDFS namespace, that is file system metadata. Name node is the one which is storing. It is not storing any user data. It is only storing the metadata pertaining to the user files.
okay,
Okay. File system metadata is stored in two different entities. First one is FS image and second one is edit log. Okay.
okay.
FS image file captures the file system snapshot at a given point in time. Okay. What is FS image? I am talking about a persistent copy which is stored on the hard disk. This is a snapshot of file system at a given point in time. It's like you taking a backup. If you connect an external hard disk now, and if you completely take a backup of your C folder to the external hard disk, that's a
Yeah, yeah, right.
snapshot. So same thing, FS image is a snapshot of your metadata. FS image contains directory and file inode information. Inode information contains the file and directory metadata. Okay, within that
Okay,
metadata
okay.
consists of file replication factor, modification time, access time, block size, the list of blocks for a given file, and so on. This is all maintained by any
Okay,
file system. The same thing, the metadata in namespace is also being maintained for name node. FS image file do not
okay,
store the data blocks to the block mapping information. The copy which is there on the
okay.
hard disk, it doesn't store the data node to block mapping information. Okay, and the writing FS image to disk is not efficient as the file size can grow to a large size. What I'm trying to say by this one is there is another copy of FS image which is running in RAM, and as you said, the RAM is somewhere in the size of 64 MB, 64 GB or 128 GB. If you try to write FS image to the hard disk every now and then, right, we will be spending too much of time in
Yeah, right.
writing the file to the hard disk. So we may miss out some of the operations, transactions. For that reason, they don't write it. That's where the edit log comes into picture.
Okay.
Okay.
So the edit log will have the complete FS images
No, no,
snapshot.
no, 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 no. It will not
No,
have.
no, okay, no, I mean. Oh, I mean, it will be keep updating.
Yes, yes. So,
Okay,
for example, let's say now the time, let me say that now the time is 10 a.m. Okay.
okay,
If at this point, if I create a FS image, whenever the FS image is
okay,
updated, once like whatever I have in RAM, let's say I write it to hard disk. Okay. Then
okay,
all the changes that are there in edit log, I merge it to the FS image copy in RAM and then I write it to hard disk. Write is done to hard disk. At this time, what happens is your edit log is truncated. All the entries in the edit log would be cleared. Edit log becomes null.
oh, okay, okay, okay,
Okay. From then on, whatever copy we have written it to the hard disk, right? That is loaded into RAM. A copy of this is loaded into RAM. So you have a latest snapshot of file system. Let's say at 10:1, user comes and tries to create a file. This particular
okay,
entry goes to the edit log. Okay.
okay,
Then let's say at 10:2 successfully writes the file. So this
okay,
commit is also done in the edit log as a record. Let's say my writing FS image to hard disk is happening every 10 minutes, which means at 10:10, okay, what name node will do is it will take the FS image that is there and that is this copy, it will merge with the changes that are there in the edit log and then create a new copy FS image.
okay.
And a new copy is
So,
again written to the hard.
okay,
And whatever content I have in the edit log would be cleared now. So the changes that we had here, right, it would be cleared, it's lost. But those changes are merged into the FS image already, which is already written to hard disk. The copy which is there on the hard disk would be loaded to the RAM now, which means a new file that is created that is also part of your FS image which is running in a RAM.
okay. So, I mean, the Reddit log is a normal text file then.
You can say, yes, it's just a text file.
Text file. I mean, so by right it will be clearing and then writing to uh,
I'll come to that.
okay.
So wait.
Now I okay,
We have a slide which talks about all these edit log things. You can actually look at this and then you can ask the question.
okay,
Edit log is a transactional log which stores the records for every change that happens to a file system metadata. Like creating a file, deleting
okay,
a file, appending to a file, creating a directory, deleting a directory, whatever you do, that gets recorded in your transactional log. Edit log is a
okay,
logical entity. It's not, as you said, it's a text file. It's a logical entity. And when you see
yeah,
physically, it is a series of files which are called as segments.
okay,
So what happens is you have a cluster of, let's say, 1,000 nodes. Okay, if you have 100 clients talking to this and if they are trying to do multiple operation every now and then, which means there are continuously entries getting created into the edit log. So for
okay,
some reason they are trying to keep all these entries within a limited size. So what they are doing is they are actually creating something called smaller files, which they call it as a segment. And like for a set of transactions, they create a smaller file and append a transaction ID to that, and they call this particular file as a segment. If we go to the place where
oh,
edit logs are stored, you'll have a set of files.
okay,
Okay, let's see. Maybe when we try to do a hands-on, we will try to go to the edit log folder and see.
yeah,
Each
okay,
segment is associated with the transaction ID and edit ID and captures the modification history. So file modification, all
okay,
those whatever we discuss, it is what it is maintaining. Safe mode. So you remember we talked about safe mode. We
yeah,
said
yeah,
name node,
yes,
did state node. FS image.
yeah,
Let's say I have a cluster created. We have written a couple of files on top of that. If I shut down the name node and restart that, this is what what it is going to do. FS image is loaded into the memory, then the transaction from the latest edit logs are applied on top of that. Once a consistent FS image is available in memory, a new FS image and edit logs are created. Okay. And safe mode is exited when minimal replication level for 99% of the file system is met. This is what I was talking, like block report is sent by every data node, and once the name node has sufficient number of blocks information, that is 99% of blocks information, it will exit the safe mode.
Okay, yeah, one point. Okay, when you say safe mode, right? Okay, and again the mm, file system image. The file system image is a RAM.
No. There are two copies. File system image, there are two copies. One is in RAM, one is on hard disk. FS image has two
Okay,
copies.
so when I reboot the server, okay, it will
Mhm.
start with the safe mode, and then it will copy the hard disk, say
Yes,
FS image to RAM.
yes.
So in that case, we could not do any write operation, since these FS images are still copying to RAM, and then it will not allow us to read any kind of block information.
Yes, you are right. You are right. Perfectly.
Okay. Yeah. Okay. So wow, once it is successful, but okay. Now, say for example, this copying to RAM might take some. It will not happen hours, but meanwhile, can I bypass this?
No. Because name node is a control. He's a master. All the bypass means if you are trying to read a file, maybe after some time it may start serving the read request, but not the write request. Okay. But till FS image is loaded into the RAM, name node is not a position to serve any request.
Okay. Yeah. Okay. Sure.
Okay, so let's come to the process of checkpointing. How whatever we discussed, let's go in a like systematic way. There is a process called checkpointing. What is checkpointing? Checkpointing is a process. All the time I was saying that name node will merge FS image and edit log. It will create a new FS image. But this is not how actually it happens. We have secondary name node for this purpose. Okay, the secondary name node is continuously monitoring the primary name node or HTTP connection, and whenever there are triggers, okay, there are triggers which are set. Whenever these triggers gets triggered, the secondary name node initiate the checkpointing process. Okay, so let's see the definition. We'll see all these details. Checkpointing is a process of taking name node file system snapshot from another system called secondary name node. Secondary name node takes the FS image and edit logs and then creates a new FS image. Okay, checkpointing is triggered based on one of the two conditions. The first condition is a periodic checkpointing. You may decide to
Okay.
yeah, you may
Sorry.
decide to do a checkpointing every 30 minutes or 60 minutes. Whatever value we have, so that needs to be set to the configuration parameter that is there in the configuration file. We'll see this configuration file, but the file that the parameter that defines the checkpointing process, that is DFS name node checkpoint dot check dot period. This is in terms of seconds. Okay, once these many seconds are elapsed, since the last checkpoint was checkpointing process was done, a new checkpointing process would be triggered. Or the second one is the number of transaction that gets appended to the edit log. If
Venkat,
it,
your voice breaks.
oh, is
I
it?
can't able to hear you.
Oh, okay. 1 minute. Is it better now? I could not able to hear. Okay. Are you able to hear now, Suma? Hello? Hello, Suma? Hello? 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 Hope you received my message. Your audio connection has been lost. Attempting to connect. Okay. Okay. Yeah, great. Now I think you should be able to hear me. Suma? Hello? 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 Hello?
Hello?
Yeah, yeah. Now
Yeah,
yeah,
yeah, right, okay.
yeah. Okay. So what I was saying is, for us to trigger the checkpointing process, we have two triggers. One is periodicity, and second one is a number of.
Yeah,
Second one is a number of transactions. We define these two parameters as a part of configuration. And internally, secondary name node checks this and it initiates the checkpointing process. Let's see how checkpointing happens. Edit log underscore in progress underscore. This is how the file name would be. Okay. And FS image. This is the one which is there in RAM. It is shown in different color. Whenever secondary name node sees that there is a need for checkpointing, it will actually connect to the name node, primary name node, which is actually in action now. It will ask that primary name node to transfer the file over HTTP connection. Internally, they use some HTTP protocol, REST protocol or something. Over that, these two these machines are transferred. Okay. When edit log needs to be transferred to the secondary name node, right, it actually truncates a file. See, this file is truncated, the transaction is updated. Till now probably there were 9 transactions. It is creating a copy of that and a new file is created starting with the next transaction. Some naming convention it is using internally, and this file doesn't have any entries now. All the entries that were there till the process of checkpointing is triggered, it is there in this file now. This file is transferred to the secondary name node. Secondary name node will do a merge and it will create a file called fs image and it will append the IDs whatever we had here with the extension called
okay.
checkpoint CKPT. This file is again
Oh,
transferred back to the name node. Okay. Name node, now it sees that the new fs image has come into picture. It will load this file into the RAM and same file, copy would be taken and replaced with the existing file that is there on the hard disk.
okay. So, why does it copies back? Okay, it's a file. Oh, yeah, fine, fine. Okay.
Okay.
So, wait. So for the first time,
Mhm.
the FS image will have null then.
If a machine is completely new, you can say, okay. If it is a completely new, there won't be any information. You can say so.
So by right, the operation will start only with the Reddit logs, and then with after a few minutes, based on the interval, so the FS image will be loaded, right?
Uh, yeah. So the way you are explaining logically, it looks okay, but I never thought in those lines. Yes, you are right. So FS image is loaded. It's for the first time. There is no file created. So I am creating a new file. You are saying that all those entries would be made to the edit logs. At whenever checkpointing is triggered, then edit log changes would be gone and merged into the FS log. Now FS image has some file content. You are saying yes, ideally it is right.
Okay, so this file image will be used for. Sorry. I just want to recollect the points now.
Okay, FS image is there in two forms. One, it is in RAM,
Yeah.
okay, and second copy is on the hard disk. The second
Yeah.
copy is on
Okay.
the disk, and whole of your metadata, okay,
Yeah.
file metadata is actually in this FS image file, which is loaded in the RAM. So the one another difference that is there between RAM copy and hard disk copy is RAM copy will have block to data node mapping,
Okay.
but the same information will not be there in your hard disk copy.
Okay.
This is
Okay.
dynamically
Now
built.
in yeah. Okay. But yeah, when I bring up the system, when my FS image is Z0, and when I want to do some kind of operation,
Mhm.
okay. So by right, it has to load the hard disk FS image to RAM FS image to do my operation, right?
Oh, okay, okay. No, I misunderstood. If you are talking about a new name node, what you said is right. But if like
Yeah.
after secondary name node writes on back to the primary name node, this is the latest one. This is an older one. This has additional
Uh,
information of this. Okay, whatever
okay, okay,
transactions that are
okay.
there in this file, those are merged into that. Let's say here we had 100 transaction and 1 to 9, let's say these were 10 transaction. This actually has 10 more additional transaction, which means 110 transaction details. This is updated.
Oh, okay, okay. So,
So at some
okay,
point name node actually swaps this. How it does I don't know, but they swap this one with the existing one which is running in RAM.
okay. So, when I reboot the
System,
system,
okay.
then what exactly happens for FS image?
See, when you reboot the system, whatever we have in RAM is gone.
Yes, gone. Right,
Yeah.
true.
So at that time, your name node enters into the safe mode. When you restart, next time it enters into the
Yes,
safe
yes,
mode. It goes and loads
yes.
this hard disk copy. Let's say this is a hard disk copy. Okay, it loads this particular hard disk copy into the RAM. Then it also goes and sees the edit logs, because when we stopped, there was no checkpointing done. We don't have a trigger for that.
Yes,
Okay, it goes
yes.
and reads your edit log and merges those changes into the RAM for the first time.
Okay.
So you have a
Okay. So I
latest
mean
file
when
system now.
yeah, so when you say FS image 1 to 9 checkpoint, okay, it is a hard drive image.
Yes, yes, yes. When this file is
Uh,
given by the secondary name node, it is a hard disk image. It has been transmitted by transferred by secondary name node to your primary name node. Now primary name node
okay,
has
okay.
to load this.
Yes, yes, yeah, true, true. Yeah, fine, 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 fine. Yeah, now because I was a bit confused. I thought these two are in the RAM itself. Yeah.
Oh no, no, no.
Okay, okay. Yeah, fine, fine. Okay,
Yeah. I think we are done with HDFS. Okay.
okay.
So it is
I mean,
7:58. Yeah.
will we sharing all the slides where
Yes, yes, yes. I'll share all the
okay,
slides with you.
yeah, fine, fine, okay. Thanks.
Yeah. Let me do one thing. So since we studied so much about FS image and other things, now, let me show you how these things look, okay, on the actual machine.
Yeah,
Okay. So logically, I can at least let me close
yeah,
this. Close this. This is my virtual machine. We will do an installation on your PC also. For time being, I'll just show you some things.
okay,
Okay. Let me go to the HD user. I will do all these things for you later on. Okay. So now, when I install the Hadoop, right, it gets installed in a folder called /user/local, because I choose to install the Hadoop here. Okay. This is my
okay.
Hadoop software. These are all my Hadoop software related files. It is in the path /user/local Hadoop.
This is of 1 point generate or is
Yeah.
the latest one.
No, 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 no. For hands-on, we don't use the latest one, because in latest one we have new features like standby name node, this, that, and all. Yarn comes into picture. It's difficult for people to learn in the initial days. So the
Okay.
major changes are with respect to high availability, the resource optimization. Yarn comes into picture, and there is one more feature, high availability and namespace maintenance. Other than that, you have bug fixes and all. To start with, this is a good place to start. You will also get a lot of
Yeah,
support and
fine.
yeah,
Okay, okay, okay.
yeah. So
I
this
mean,
is
in
yeah.
the sorry. Now in the companies also they use out of one or two.
So if you ask me this question, it depends upon the requirements of a company. Let's say you have a company, you have a requirement where you want to run MapReduce job as well as some other jobs, Spark jobs. Then obviously you have to go for Hadoop 2.0, because Yarn comes into picture, and Yarn as a service provider, right? It supports both MapReduce and Spark and other tools. Okay. Now, if you are
Okay,
setting
okay.
it up for the first time, where you are doing everything based on MapReduce, then there is nothing stopping you from using the Hadoop 1.0. So we need to see for
Okay,
what
so
purpose.
so
Yeah.
yeah. Now for our practice, will it be? Will this not come into picture, or we can still manage to do a use zookeeper and all those things.
No, no, no. We can do everything here.
I'm not sure.
We can do
Okay,
everything.
okay. Yeah, fine.
Maybe what you can try at the end of this session is once we do all the installation using Hadoop 1.0 and do hands-on now, at the end of the course, you can actually try to repeat the same thing for 2.0.
Okay, yeah, fine, fine, fine. Great. Yeah.
Yeah. Uh, Let me and latest version of Hive and other things. Now they have additional features supported and also which so more of bug fix and enhancements and all. So let me go to a folder called config. This is where we have all those configuration files. Okay, all lot of
Okay,
XML files. Okay, see
okay.
masters, slaves. I was talking about these files right yesterday.
Yeah, right.
So today we don't have anything in this because it's a single node. This one it only says localhost. Let me see what is there in slaves. So everything is localhost. All the processes are running on the same one. So we are saying localhost. Let me open the XML file HDFS site.xml.
Okay.
Okay. So there are two files. There are primarily okay. We talked about so much about HDFS, but all I was also talking about configuration parameters and all. So there are primarily three
Yeah.
configuration files when it comes to the core Hadoop HDFS. One is for MapReduce, one for the complete cluster, and the last one is for the HDFS. So we have a Hadoop, that is this one, and we have HDFS within Hadoop, that is this configuration file, and within Hadoop we also have a MapReduce. So this is a configuration for a file for that. All these configuration file you will not be able to see in any of the installation folder. These are default ones. This is part of the jar files. I have extracted it. Okay,
Okay.
so I can send it to you, but if you try to find in that installation folder, these files will not be there.
Okay. Then how did you get this?
You remember grep code yesterday I showed you?
Okay.
So I went to there. I was looking in what path they have put, and after that, somewhere
Okay, okay, okay. Yeah,
I found.
got it. Okay.
Yeah, I found
Yeah,
somewhere
yeah,
this
okay.
path. I don't know how I copied it and all. Somewhere I found the link and then I downloaded it to my local PC. I did some time back. The
Okay.
reason why I'm showing it to people is so that they will get a feel like what is a default file and what is a user level files and all.
Okay. Okay.
And tomorrow, if you want to update and all, we can always copy this and play around with these values.
Okay.
See, yesterday I was talking about the IP address and all. Okay, so this is where the secondary name node is running. Today, all our clusters are running on the same. All our daemons are running on the
Same number.
same machine, so it's a local host. And this is a port number. See, the data
Oh,
node is
yeah.
running on this particular port number. So data node also has a HTTP
Mm.
version. Okay, that is running on this port number. So IPC mechanism, something they are handling internally. So those are these port numbers. Okay, now data node serves the clients. How many handles should be there? The number of server threads for the data node for parallel execution, they have set it to 3.
Okay. Oh, this is basically all kind of a parameter files
Yes,
for Hadoop.
yes.
Okay, okay.
See, for name node, so they are saying how many server threads should run in parallel. 10. So the safe mode, when
Yeah,
should the safe
okay.
mode be exited? So by default, they are putting 0.99. You saw there, right? The same thing is here. If you want to change
Yeah.
this, you can change this.
Also, this we can change, and we can reboot the system, and if we give like something like a 10 minutes or till 10 minutes later, it will not release from the safe mode.
Yes, all those things you can try. Yes.
Yeah, right. Okay.
See here it says specifies the percentage of blocks that should satisfy the minimum replication requirement defined by replication min. Value less than or equal to 0 mean not to wait for the any particular percentage of blocks. You can set the value to 0 also.
Okay. Okay. Okay.
Okay. Okay, this is your minimum. Okay, minimum data nodes specifies the number of data node that must be considered alive before the name node exits the safe node. It should get a block report from some name nodes and all. So a lot of parameters
Okay.
are there. We'll not be able to spend time on this, but in your free time, you can actually look into this. Replication. Let
Yeah.
me say
Fine.
for
Fine.
replication. Replication interval. So the periodicity in second in which the name node computes the replication work for the data node. Okay. This. DFS replication. See here, DFS replication, it is set to 3 by
Okay.
default. Okay.
Okay.
And replication max.
No, by right. Okay. I mean, if I'm an admin, okay, do I need to edit this file, or will there be any other interface where I will go and says the parameter values, for example, there are
I understood.
replication 3, 2, or 4. Yeah.
See in Hadoop, Apache Hadoop, the open source, you don't have a GUI interface. Maybe in Cloudera and Hortonworks, they would have provided you a GUI interface. Cloudera and Hortonworks have some managers tools. Okay, Cloudera has
Okay.
a CDH manager or something, and Hortonworks uses something called Ambari to manage the cluster. There you might have options like
Okay.
that.
Okay. Yeah. Got it. Got it. Got it.
See the minimum
So I mean,
replication. Yeah, yeah.
yes. Sorry. Okay. Are we working on any
No, no, no.
Cloudera for this practical?
No, no, no. We are not working.
Okay, okay.
See, this is a minimum replication factor. So the moment we have one copy of any block created, name node will wait. It will say the write is done. And see, this is where the
Okay.
block size is defined. This is your block size. It's in bytes, I think. Let me, take this.
Okay. Divided by
Yeah.
10241.
1024 divided by
Yeah,
1024.
it's
64 MB.
yes, is 4 MB. Right. Okay.
Okay. So you can change this. If you want to change this to 128 MB or 256, you can do that. As we discussed earlier, so
Yeah.
performance will be affected.
Yeah. Yes. Yes. Okay.
Okay, so this is about the core this one HDFS related thing. We have another configuration file called core-default. In core-default, okay, where is the first parameter? See, this is a parameter which tells to the Hadoop file system where the HDFS folder should be mapped on the Linux file system. This is your Linux file system path. All the Hadoop file system files would be created under this file folder.
Okay. Oh, the entire framework will fall under slash temple slash Hadoop.
Not framework. When we do the Hadoop software installation, the installation is happening in this folder. See, the installation, I did it in this folder. Unzip and all right. I did that one in this
Yeah.
folder. Now, when you start writing file.txt to HDFS, it needs a physical storage, right?
Yes, okay, no, I mean, now for example, when you try to install Hadoop, right, it
Mhm.
will ask for some path by right?
Yes.
Okay, I mean, if it asks for some path, okay, under that path, it will go and install the complete software, or we call that the framework, and then under that framework, okay, you will create a DIRs and all, and then by using the commands, you will dump the files from Linux to Hadoop path. Is
Uh,
that so? It
You are right. Just let me, clarify a couple of points. Maybe if you have any questions, you can ask. Okay. First, I want to install the Hadoop software. What I did, so nothing is stopping me. You can install wherever you want under Linux path slash user local.
Yeah.
Okay. Generally, this is where we install the software. I created a folder called Hadoop. Okay.
Okay.
And
So
from
this is a normal, sorry, this is a normal Linux folder like
yes,
mkdir Hadoop.
yes, you are right. This is a
Okay.
Linux folder. So I haven't installed
Okay.
Hadoop yet. So I'm in the Linux operating system.
Yes.
In Linux operating system, I go to this path slash user slash local and I create a folder called Hadoop. From Apache website, I download the Hadoop software in the form of tar file.
Okay. Great. Okay.
I untar the tar file, then it opens up lot of folders. Okay,
Yes.
this is my
Okay.
Hadoop software.
Yeah.
Then to set the path of Hadoop software, I go to my bash RC and update